Hey guys, John here. This is a tutorial on processing LRGBHa data. So the sample data has been uploaded to the Google Drive, so you guys can download and follow along as we progress. And the tools that we're going to be using are PixInsight, 3RC Astro tools, which are NoiseX, StarX, and BlurX, and some third-party PixInsight scripts. So I'll be putting the repository information down in the description so you guys can download if missing anything. But before we actually dive into the processing part, I wanted to give a general overview of what we'll be doing in terms of the full flow. So initially we have 5 linear data files, which are LRGBHa. And first thing we're going to be doing is we're going to be doing background extraction to remove the gradients and maximize the contrast. So there are many tools that can do this. There's this popular tool called Graxpert, and some PixInsight's own tools, which are automatic background extractor, dynamic background extractor, and gradient correction tool. But this can be actually applied individually for all 5 files, and then RGB image can be combined after. But I found that sometimes combining the RGB and doing the background extraction works better. But I believe if the light pollution is very heavy, it is certainly better to do generally to do background extraction on all 5 before generating the RGB image. But you guys can play around with it and see what works best. And but yeah, the sample data that we're going to be using, I believe it doesn't make a lot of difference. After we do the background extraction, we're going to be doing sharpening or deconvolution. The tool that we're going to be using is Blur Exterminator, but I believe other deconvolution tools will work as well. And after that, we are going to be applying a little bit of denoise, not to the full extent, and we're going to be doing star extraction on linear data. We are going to be processing this red channel separately because we're going to be using it on this thing called Continuum Subtraction. So, but I'll get to that later. And for this RGB image, when we do the star extraction, we are going to be generating a separate RGB star image so that we can stretch it and combine it in the final image. And so this linear H alpha and red data, we're going to be doing what's called continuum subtraction. So red channel mostly has continuum light from stars and a little bit of HA emission as well. And HA channel has mostly HA emission because it's shot from narrowband filter, and has a little bit of continuum light as well from the stars. So what we want is we don't want to oversaturate the image with red, and we don't want to be adding what's already been added with the LRGB image. So we want to generate this clean HA emission only image to be added to the LRGB image so that we can increase the contrast for just the HA emission part. And yeah, this is the formula that is used for generating the HA clean image, but we'll be using the script in PixInsight's own included plugin. But yeah, after we generate this HA clean or HA emission only image, we're going to be stretching the data and actually combining them. So we are going to be stretching with in the tutorial. We're gonna be using GHS, but there are other stretch methods out there like mask stretch and histogram stretch as well. But I believe GHS and mask stretch work best for bring out the subtle transitions of the data. But yeah, after we stretch, we're gonna be doing what's called image blend, and we're gonna be creating this LRGB image. So quick note about this LRGB blended image. So luminance brings the faint details to the image, and RGB adds the color data. But since we are adding this color data to luminance, which is of course just a black and white image, a lot of color depth is lost, and the image usually turns out a little bit blue and a little bit magenta, and losing a lot of that yellowness of the pure RGB image. So after we blend it, we're going to be doing a little bit of color correction, and of course boosting a little bit of saturation, so that we can at least retain a little bit of naturalness to the LRGB image. We are going to be also stretching the HA clean image, and we're going to be mapping this image, because this is a mono image. We're going to be mapping it to red, and then blending these LRGB and red image together so that we have a starless LRGBHa image. And then we are also going to be stretching the stars and combining them all together to have the final result. So yeah, that's the general overview of the processing, and let's get into the actual PixInsight tutorial. Right, so this is the PixInsight portion of the tutorial, and just a quick background on the acquisition data that we're going to be using is this was shot about 2 years ago from Fraser Park, and which is about Bortle 3.8, and the acquisition time was quite short. It was only about 7 hours and 47 minutes in total, and as you can see in the HA, the HA ring that's supposed to be here is quite faint, so can certainly use longer integration time if you're planning to do it yourself. But yeah, I'll be using this data for demonstration purposes. And but yeah, to begin with, we're going to be going to process, channel management, and channel combination to generate the RGB image. Select RGB for each channel, and we're gonna be pressing the circle, which is apply global. This is if we click this, it's gonna be trying to apply to this image, which we don't want to do because we are going to be processing this luminance as well. But yeah, this is gonna be the RGB image, and of course it's not color calibrated yet, but we're gonna be calling this RGB, and we'll get back to that later. And the next part is the background extraction, and so quick information regarding background extraction for this target and this framing. You can either use well, a popular tool called Graxpert, or PixInsight's own tools, which is automatic background extraction and gradient correction tool. But as you can see here, the Graxpert certainly brings out more contrast in the reddish faint regions of the nebula, but it certainly gets rid of the like a lot of details in the bottom right region. And also if you zoom in to this region, you can see a lot of the color color transitions have been lost for Graxpert compared to just automatic background extracted image. So, but yeah, it certainly has a lot more green, which is what will, I believe it can be calibrated and it can be adjusted. So what we're going to be using for this specific um, target and this specific framing is we're going to be just applying automatic background extraction and some little bit of a gradient correction tool. But yeah, we can start off with luminance and go to process background modelization and automatic background extractor. And we're going to be using function degree of 2 and correction method of subtraction. And we can certainly discard the background model and replace the target image. And press apply. And now we can see that the major gradient that we seen initially has been extracted. But you can still see a little bit of remaining gradients here. I chose function degree 2 because if we go more than 2, it can kind of be aggressive, and I like to clean up with go to processes and gradient correction, and yeah, I don't mess with the parameters. I think the default value works fine for a cleanup, and you can see yeah, this whitish portion of the gradient is gone, and it's more flattened out now. So but yeah, we're going to be applying that to as we discussed before, luminance, RGB, and the red channel, which is here, and the HA channel. All right, so we have the background extracted, luminance, red channel, HA channel, and RGB image. Now we're going to be applying deconvolution to these 4 images. But first, let's go to script, image analysis, and full width half maximum eccentricity. And select the luminance view and measure the medium full width half maximum value, which should theoretically give the biggest value. And press support so you can visualize it a little bit better. And but yeah, we're going to be using that value 2.659 to the deconvolution tool. So go to process, RC Astro, and blur exterminator, and uncheck the automatic PSF because usually it doesn't really work very well in my opinion. And we're going to be applying the median value that we found, which is 2.659. And yeah, it usually rounds it up to the second decimal. And sharpen non-stellar, for this data, we can certainly go up to 1.0. But if you're shooting with an SET and very bad seeing, sometimes you might need to lower the value a little bit because over sharpening can certainly happen. But yeah, we're gonna be first checking the correct only, which should correct the star shapes first, and that will also correct this chromatic aberrations in the RGB image as well. Right after that, we're going to be unchecking the correct only and actually applying the stellar and non-stellar adjustments. All right, that looks good, and we're going to be applying this to all 4 images. So I'll fast forward this part. Right, so deconvolution has been applied, and now we're going to go to the RC Astro noise exterminator, and we're going to be applying the initial denoise somewhere around 0.6 to 0.7. I'll just do 0.7 here. But yeah, we're going to be applying this to all 4 images. One thing I forgot with RGB is go to process spectrophotometric color calibration, and we're going to be color calibrating before we apply the denoise. So this image was shot with Antlia RGB filters. We're not going to be generating graphs, and press apply. Right after that, we're going to be applying the noise exterminator as other 3 images. Right, so we have denoised luminance red HAN RGB image. Now we're going to be extracting the stars. So go to RC Astro and Star Exterminator. And so for RGB image, we're going to be generating the star image, but do not check unscreened stars because this is only for stretched images. So these images are in linear state, so we do not want to apply that. So yeah, I usually check the large overlap because it certainly does better for general purposes. Right, that looks good. And yeah, we can name these. We can name this image stars. And but yeah, we'll get back to that later. And yeah, we can certainly close this as well. And now for the rest of the images, we're not going to be generating the star image. So uncheck that, and we're going to be extracting the stars so that we can process it from starless state. Right, so the next step will be to generate a continuum subtracted image from red channel and HA. So go to script, toolbox, and continuum subtraction. And we're going to be selecting R for red channel view and H for narrowband view. And click on show black pixel. And as you can see, if we increase the amount, we can certainly see the black pixels are growing, and if we decrease, you can certainly see that they're going away. But we don't want to have the amount that is too small, which does not subtract this continuum light region. And we certainly don't want to make it a little bit too big where we're clipping off these region in black pixels. So for this specific example, I believe about 0.13 to 1.2 is good enough. And if we start like going to 0.14, you can certainly see the black pixels are going hard a little bit. So for this example, I'll be using about 0.136, and after that, click the check mark. So yeah, this image, we're going to be calling it HA clean. And yeah, that's pretty much it for generating the linear images, and we're going to be now stretching them. Right, so we have 4 images ready for stretching. So we have luminance, HA clean, and stars, and the RGB image. So let's start off with luminance, which should be the easiest. So go to process generalized hyperbolic stretch, and click on the circle marked for preview, and we're gonna be resetting the stretch so that we can actually see the stretch result. So initially, I bring up the stretch factor to about the point where the peak of this curve hits about the middle point of the first initial cell. So that's and you can see that it's somewhere around here, and that is going to be the first initial stretch factor. And I bring up the local intensity to the point where just before the background starts to turn gray. So you can see uh, increasing the local intensity certainly flattens out the bright parts, which is good, because we don't want to overstretch these regions. And but if we bring it up more, you can see the background starts to turn gray and a little bit whiter. So we want to I think this point, oh yeah, this point is just about where just about before the background starts to turn gray. So yeah, we're gonna be using that value, and press apply. And after that, we're going to be applying just a tiny bit of denoise. So about like 0.4 is what I like to use. Right, that's done. And after that, I pick around the little bit to the right from the peak point, somewhere around here. It can be a little bit more to the right. So I click on the graph, and I click on send to SP, which is a symmetric point. And we're going to be stretching to about I think for this data set we can stretch about 1.78, and local intensity bring it up so that we can increase the contrast a little bit better. Yes, I think 2.99 surely is good enough. And yeah, you can see the background certainly needs to have like black point needs to be raised a little bit. We'll get to that later, and we're gonna be applying the same exact stretch for RGB image. So reset the view, and we're gonna be stretching to the middle point of the cell, and bring up the local intensity. I think that is the good point. Good part. Wait, no. And that is good enough. Yeah. Okay. And apply 0.4 denoise. And pick the little bit right point of the peak, and then send to symmetry point, and then we're going to be stretching it about the same as we did for luminance. So yeah, that looks good enough. And now we're going to be putting that aside for now, and we're going to be stretching the HA clean image as well. But for HA clean, we don't really need to stretch so aggressively as we did with luminance and RGB image. But first, we are certainly going to be stretching to the middle point, the same way as we did with luminance. I think that is yeah, that is certainly a good point. So okay, so apply, and we can apply the denoise 0.4. And next we're going to be we're not going to be stretching too aggressively, so pick a little bit more right side of the peak peak point, and then stretch to about, I guess, 1.2 or 1.3. I think 1.2 works fine. And local intensity will swell. We're not going to be stretching that much. I think 2.5 is enough. But yeah, let's do that. And after that, we're going to be increasing the contrast a little bit. So go to curves transformation and bring down the left side curve and curve it a little bit so that it can increase the black point a little bit. Press apply. Yeah, that looks certainly better. And now go to process HDR multi-scale transform, and we're going to be having the 2 intensity and lightness mask checked on, and let's apply it so that we can reveal more details in these bright parts of the nebula. But that looks a little bit grainy. So let's try 7 layers. Yeah, that looks certainly better than this layer 6. But yeah, after that, go to script and utilities and MB color mapper, and we're going to be selecting the HA clean image, and hue we're going to be setting it to 0 because we're going to be using the red color, and saturation I usually put about 0.85, and press update and click on the check mark to generate the red HA image. And yeah, that looks good. And now we're going to be stretching the stars, which is quite the easy part. So reset the view, and so I usually stretch to so bring up the stretch factor to and see how much stars we actually have in this frame, and I usually bring it up to about 60% ish, 60 to like 70, and I think here about 6.75 or 6.5 is good enough, and bring up the local intensity so that so here, as you can see, you can bring down the core brightness a little bit, and make it a little bit softer so that the surrounding stars can be a little bit more resolved. So here I'll be doing about I think about 2.5 is good enough. So let's click on the check mark. Sorry, the square mark. And what we want to do is we want to at least resolve these like stars that are really close together. But yeah, not to the point where it's too small and not showing a lot of stars. So but I think this is certainly good enough, and yeah, we'll get back to the star image later. But now let's go to utilities, image blend, and we're going to be actually creating LRGB starless image. So click on L for base image, and click on the RGB for the blend image. And for blend mode, we're going to be selecting color. And yeah, you can certainly see that the black point is quite not pushed enough. So we're going to be putting about 0.2628 is good. And bring up the black point. I usually bring it to about twice as much compared to luminance, because it helps with the color noise in the background. But yeah, that looks good. And also bring down the midtone a little bit so that it can blend a little bit better. The colors can blend a little bit better. And yeah, that certainly looks good enough. And we're going to be pressing the check mark. Right, so we have our initial LRGB image, but it certainly feels too whitish. So we're going to increase the contrast a little bit. So click this icon, which should generate a luminous mask, and press Control I, which should invert the mask, and apply it. So drag it to this image. Oops. Yeah. So yeah, that's a clone function, but drag it to the image blend image. So press Control K to unshow the mask, and now we're going to go to the curve transformation. So this luminous mask, reverse luminous mask, should theoretically protect the luminance a little bit, and um, not let us stretch too much excessively. So bring down the left point of the curve, and I usually set it to about I think that is good enough for the contrast. But yeah, that looks good. And after that, we're going to be generating a mask. Go to mask generation and range selection, and because like these regions are quite bright, and we can certainly bring out a little bit more lines of gas in these specific regions. So increase the lower limit to the point where it's covering the regions that we're interested in, and bring up the smoothness so you can generate a more smoother mask. But I think this is still quite not smooth enough. So go to all processes and go to convolution and increase the standard deviation, and let's apply it to this image. And yeah, that looks certainly better. And apply the mask to this image blend. Press Control K to confirm that we have the mask applied. And go to all processes and HDR multiscale transform. I think we can use I think we can use 7 layers, but we do not need to set the lightness mask because I already did. And yeah, we can bring down the intensity a little bit. I think if we apply to the full 1.0 intensity, it can certainly look like this, which is, I guess, yeah, it does show the lines of gas, but it looks a little bit too overly processed. So well, this is very subjective, but I like to keep it a little bit natural, so I'll do about 0.7. But yeah, that certainly looks better than the previous, in my opinion. But you can certainly do it to full intensity if you prefer that style of processing. But yeah, after that, go to local histogram equation and press preview and increase the kernel radius a little bit so that so what I want to do here is I want to increase the contrast for the lines of gas for the more of the bigger portion of the nebula. So I think 120 is certainly good enough, and bring it down to about I think 0.25 is good enough, so that we can have a little bit more defined lines for the gas structure. But yeah, that certainly looks better. This is before, this is after. But okay, and now we're going to be applying saturation to the image. Generate a luminous mask and apply to the LRGB starless image, and go to curves transformation and select the saturation, which is the rightmost box, and we're going to be applying it incrementally. First, apply about this one. Oh, that is a little bit too much. So let's apply about half, and I think that is certainly the maximum I would go with this saturation. And since this is a little bit too green, I'll be using the SCNR tool. Go to all processes, SCNR, and I certainly do not want to go full on, so I'll be about 6.25. Remove the mask first and apply it to the image so that it doesn't look too dirty with green. And now, as you can see that well, if you look at the RGB image, let's say we increase the contrast as we did with like this image, you can see a lot of the yellow or red gas has been yellow red color has been diminished here, and a lot of blue and magenta is boosted. So what we want to do is go to script and toolbox and selective color correction, and select low saturation for the mask, and bring down the magenta, and I like to increase the yellow and decrease the green, because we don't want that green, but make it more like reddish in the part of the nebula. So that looks certainly good, and increase the saturation a little bit, about 14. But yeah, it certainly brings the yellow parts of the nebula a lot better. And let's press apply. Right, that looks certainly better. And but yeah, that's the LRGB image that we're going to be using. And now the next part is blending in the HA image that we generated, which is here. So go to script utilities image blend, and we're going to be using blend mode screen, and select the image blend for the base image, and the MBCM image for the blend image. And of course, this is way too severe, so we're going to be increasing the black point of the HA image to about yeah, this is really personal preference too. So I think that is a little bit too small. I think just about here is good enough, or where it's not too blown out with HA, and it has those subtle transitions, which are these parts, and you can faintly see the ring here too. And but yeah, that certainly looks good, and we're gonna press the check mark. But yeah, this is the HA blended LRGB image that we get with this. But if you're a pixel peeper, you can certainly see that the bluish region that we have in this LRGB image is kind of I'd say masked with a ton of HA in this region, and this is actually quite common. So what we want to do here is we want to yeah, we're going to be closing that image with yeah, we want, what we want to do here is we want to kind of protect these this specific region when we actually do the blending. But what we want to do is we don't want to protect it too aggressively, because if we do that, then the image will certainly look not natural. So what we are going to be doing is go to script and SETI Astro and Fame script, and zoom into this specific nebula that we're interested in, and we're going to be drawing this oops. So we're going to be drawing this the part of the region that we want to protect from the HA. And I believe blend amount can be about 60, which is good enough. Oops, wait, that's we can ignore that. But we're gonna be generating a lightness mask, not a binary mask, because that will certainly cut out a lot of HA, but it will certainly look unnatural. So generate a lightness mask, which should look much natural. Yeah, we're not going to be using this, but what we're going to be doing is Control I so that we can invert it and apply it to the image blend, LRGB image, and press Control K so that we know that this the mask is applied. And go to script. We're going to be doing the same exact image blend again, but yeah, now we're going to be pressing apply. But now you can see the bluish region is a lot more protected than the initial image blend that we did. Other technique that we can utilize here is we can actually increase the highlight a little bit here to I guess bring up the ring structure a little bit better. But this certainly will yeah, certainly will intensify the background HA as well. So we want to adjust that, and we certainly want to bring down the midtone a little bit so that it can blend a little bit better. And yeah, I think that looks good. All right, let's click apply. All right, now yeah, now we have the LRGBHa blended image, and all we have to do now is put back the stars to the starless image. But before we do that, I usually like to use SENR to remove all the green and saturate the stars before we actually put it back. So put a luminous mask over it, and I stretch about to the point where it's not unnatural. So if we stretch more here, you can see that this transition is starting to show a lot better, a lot more apparent. So I think this is the maximum point that I'll go. But yeah, that looks good, and we're going to be combining the image with pixel math. So write combine op screen underscore screen and parentheses, and go to expression editor, and click on the image blend 2, which is the starless image that we want to merge in, combine, and double click stars and write comma and press OK. And for destination, we're going to be creating a new image, and press the square button, and now we have the star combined image. But before we actually do this, I usually like to apply a final denoise to this image. So go to noise exterminator, but for this one, I like to separate the intensity and color a little bit. So first, I like to denoise about 0.5 or maximum 0.6. And denoise color, I usually like to go a little bit stronger. So oh wait, let's remove the mask. About 0.7 should do. Right, that looks good. And now we're going to be combining the image. So that sums up the processing tutorial in PixInsight. Hope you guys enjoyed, and thanks for watching.